Hey guys, Alex here. It's March 2021. It's the anniversary of our pandemic, isolation, working from home, most of us, and some weird things are happening. But today I want to talk about the silver lining, because every cloud is supposed to have a silver lining. What I'm noticing lately is a number of people approaching me, or maybe in a casual conversation, and started thinking about ways to change the ways they work. And of course, everything's changing. But now is a chance for us to examine what's going on, have a cold, hard look into what we were used to be doing and how things are changing. Now, in a broader sense, my approach here, and this is going to be a little bit of a rant before I actually zero in on a topic I want to talk about, is this transformation from the more industrial age mass production mentality, where we were mostly concerned about just making things, and we call it the focus on the made. So we're making cars, we're making refrigerators, we're making all kinds of products, phones, computers, and the focus is just on making, while the process of making was of secondary importance. You have your conveyor belt, your assembly line, you just go and push things. Things started changing maybe 40 years ago, 35 years ago, with the lean approach, where the inventory all of a sudden became a liability instead of being an asset. That was a major kind of a radical change in thinking, and to this day it still poses a challenge to many organizations to actually grasp with the fact that having a bulky inventory and piling up the made is actually a liability, and it's a problem. And so we're seeing this shift from just making, producing, more switching towards the understanding or improving the process of making. And as soon as you start looking into that, you realize that actually it's all about the makers, us, who are making things or making services or doing something. And so this is a very beneficial transformation, and I'm not the only one talking about this, of course, but it's significant because my profession and my practice is all about software engineering, and I think we are kind of spearheading that, because we started some 25, let's say 20 years ago, to completely do the makeover and about face and change the way we do software. And nowadays I'm seeing more and more people who even have nothing to do with software engineering and don't care, but the meme or the mentality or the mindset is changing, and people are starting to talk about agility, lean, eliminating waste, and even DevOps, and all these new things that people are becoming interested in because they want to improve the conditions of their workplace, of their lives, and indeed it is very beneficial. But the problem is, when I talk about how I'm helping people transform their practice and their workaday lives, it's all about software, and we have very, very crisp, clear discipline, or a couple of disciplines that we are practicing, that is relatively easy, because we can work with computers to help us get there. And what it really boils down to is testing and testability. So that's the cornerstone. Like you got to be able to focus whatever you're doing. It has to be testable, and you have to convince yourself and others that what you're doing agrees with the test, and that you're not just kind of winging it and doing something and shoving it out the door, and then later on realizing, oh, this is not really what we wanted to actually ship. And that's fine, and we talked about that in other areas, and it's called test-driven development, and the agility and all these other great concepts, but they're all somehow related to software engineering. Now, if somebody's not doing software engineering, they would like to be able to make that transition, but how do I write a test It's easy to write a test that's going to check the code, the behavior of the code, and tell you whether it meets the expectation or not. But in some other areas, how do I start with testability in mind? Because of course, the two things about testability is, one is that it should be really focused on starting with a broken situation. So first thing you do is you have your system broken, and now you see it being broken. It's actually impetus for you to start fixing it, right? And that is something that is very kind of obvious and easy to do in the world of software. And now I want to talk a little bit more about how do we maybe translate that into other activities. Another also beneficial thing of having this approach is, once you have, you break your system, but first writing the test and the test fails because the expectation has been met, then you make the system, change the system so it meets the expectation. Next thing is, as you keep doing that, you all of a sudden realize that you have a nice little collection of tests that are your safety net and that are your guardians or goalies, so that in the future, if something inadvertently changes and it's all of a sudden, it used to work, but it all of a sudden changed and it doesn't work, tests will let you know immediately. And so tests are your really goalies and your goalkeepers. And the third thing is also, as we are taking this approach to testability, we realize the benefits of small batches, and we are chopping things into smaller little areas, and instead of chewing off a huge bite and we start choking on it, we go chop it into tiny bits, and every step of the way we exercise the entire system. We see it's not broken, and we break it again, tiny breakage, fix it, and keep moving. That way, as engineers, we are really shining. We are doing an awesome job. And I can explain all that, and I've been explaining all that, but now when people who are not doing software engineering, they want to do the same thing. And so I was thinking about it, and I came up with a little bit of an analogy. And in order for people to understand this discipline, people who are not programmers, I wanted to offer a presentation and some hands-on exercise so that you can, those of you who are not doing computer programming, you can understand where we're coming from and what does it all mean. So I now invite you maybe to go over follow me. I'll go over the presentation, and I'll do a little bit of hand coding or writing. And then maybe you can later on approach me. You can ask questions or send comments, and we can talk some more. But for now, I'm really keen on offering to people who are not technical this example, and I'm really interested to hear what are the impressions. Does it make sense? Did the light bulb go on in your head? And then we can maybe improve and make it better, and so that everybody can benefit from this transformational event that's happening. More and more we're staying home, the economy is changing, the sources of income may be dwindling, so we have to find another way of earning money, earning a living. All these things are, at the same time a little bit, scary, but also very exciting. And let's see how far we get today, and hopefully we can improve and make it better for tomorrow. All right, next thing, my presentation. See you there. Thank you.
Welcome to Test-Driven Development for Non-Programmers. What do we mean by test-driven? First of all, we don't mean that somebody today should be taking a test. We want to first talk about what is a test. And my way of formulating a test would be a formalized expectation. So we can have various expectations, and if we are communicating expectations among ourselves as people, we are using common sense, and it is not necessarily formal unless we are dealing with some formalized institution. But when we are trying to express our expectations to the machines, then they don't possess common sense, so we have to come up with some kind of formalized expression. And that's what we mean by a test, a formalized expectation. And now, basically, we call it formalized if the expected behavior is repeatable. So for example, let's say I'm building a chair and I start to build a chair. Now I'm not gonna spend a whole day building a chair without ever checking whether when I sit on the chair will it support my weight or not. That would be kind of foolish. So I'll be repeatedly, as I'm building, trying to sit on a chair to see if it's sturdy enough. And same goes from any other activity, pretty much any other activity. If we're building a house or a bridge or anything like that, we have to, as we're building, we have to keep testing and checking if everything is okay. And that, expected behavior, such as the chair will not collapse, is repeatable. We can check it over and over. How do we make that expected behavior repeatable? So we need to formulate our expectation so that it talks about the conditions that are necessary to produce the desired behavior. For example, if I go and deposit $100 to my savings account in the ATM machine, then my expectation is that my account balance will rise by $100. For example, if I originally had $500, when I deposit $100, it should now go up to $600. And this new balance is what I expect. This is the expected and the desired behavior of that ATM machine. And if I repeat that behavior and I put another $100 as a deposit, then I should see $600 bump up to $700 and so on. So each time I do that, the machine should behave the way we expect it to behave, and therefore we are testing it, fulfilling the expectation. And we call it test confirmation. And by repeatedly confirming that the machine meets our expectations, we can say that we have successfully tested its behavior. Now, if we think about how we did it, we realize that this mode of testing is rather tedious. We're doing repetitive manual testing. It's time consuming, it's error prone, it's a chore, and it's not something we're looking forward to doing. Therefore, we feel like we must automate it. And the good news is that we can write our expectations in the form of a script. So we are testing by scripting. Because computers can read our test scripts and can then verify on our behalf whether our expectations that we described in the scripts are being fulfilled or not. This is called testing by scripting. The question now is, how does the computer know if the test passes or fails? And the answer is that the computer checks for the behavior. Once we run the script, the machine produces some form of behavior, and then the computer asserts whether the produced behavior is as expected or not. And the computer does that by comparing expected values, the ones that we defined, with the produced values, which are the ones which result from the computer operations, from the machine running. So all that is great and fantastic, but what if I don't know how to program computers? What good is this for me? And there's no use me trying to explain programming, and there's no interest in that, and this presentation and this session is absolutely not about computer programming. So we want to show here that we can do test-driven activities without programming the computers, right? And one example I've chosen to do today to show you how this process of test-driven development works is to do a familiar thing. Everybody's familiar with this, which is writing a short story, and we'll try and do it using test-driven approach. So how do we do that? I mean, everybody's familiar with writing short stories. We did it in school and maybe as a hobby project, but we are not doing it by writing tests. First, we have different methodology. So the question is, how do we do test-driven approach? My suggestion and kind of way to illustrate this is to start from a broken system. And usually that is like, what do you mean broken system? It doesn't make any sense. It usually raises eyebrows. So we can always start from a broken system. In our case, for example, by saying, look, when we write a short story, because we are not writing it on paper, we want to make sure that once we power off the computer, it does not disappear. So we want to save it. And usually we save it in a file. But we don't have the file, right? So we will start our writing activity by first not having a file. We will test the system. And because we don't have the file, the system is broken. Now sometimes like, how is this how is this broken state helpful? It looks kind of non-productive, but in reality it's actually much better to start from a broken system than to start from a system that apparently is not broken and then assume that a lot of the things are already taken care of, which they may not be taken care of. And so I'm always more comfortable when I start with something busted and then I fix it, and then I know, because the way I fix it, I know it's working. So since the approach here is similar to that. And another thing is, when we working on something that is broken, then we feel the urgency to fix it, and that is giving us motivation. So in this case, we start by seeing the system is broken because the system cannot find the file where the short story should be saved, and we are kind of stuck at that point. And because we're stuck, we should be prompted now to create that file. And that problem is solvable, and we know how to solve it. We know how to create a file. So that there's a small illustration of what does it mean to start from a broken system and then feel the urge to fix it. And the next step is you fix it and keep going like that. Okay, so now we create the file. But what do we do next? What's the next test, or how do we break the system again? Now we think, at this point, we stop and think and ask ourselves, what is our next expectation? Okay, we have a blank story file. What's the next thing? And to begin with, we can always say, look, it is customary that a story will have a title. And so we need to express the expectation that the story should have or must have a title. How do we do that? We use the formal expression, which I've bolded here, and it's called must contain column title. This is the imperative. This is something we communicate to the machine to say, look, this story must contain title, and this imperative or this expectation is formulated in this unit tests.txt file. And so now you may be thinking, well, I don't know what that file is. This file comes with this little system that I built. It's baked in, it's there, and it's awaiting it's giving us a blank canvas where we can put our expectations. And these expectations will drive the writing of the short story. So next thing we want to do is, since we know that we need to start with a title, we should probably now roll up our sleeves, stop talking about in general, and start doing it. So for that purpose, I have created a little folder which I call TDD short story, and this folder is in here. I've separated into two subfolders. One is stories, another one is tests. And in the tests folder we have unit test.txt, which is this one here. And this is a place where we want to declare our expectations. But before we do that, let me first run the system, because we talked about having to start from a broken system, and because we do not have the file, let's see how the system behaves when we run it. We run it by doing the command run test. That's simple. It will run and it will fail. You can see here it tells us that it failed, and the reason is file containing the story is not found. So the system is telling us what's wrong, but also it elaborates and says, I was expecting to find a file named short-story.md. I couldn't find it, and please create it to move forward. So now we need to create this file shortstory.md. Let's just flip over and do it. It should be done in the stories folder. So we are saying short-story.md. Now MD, the extension stands for Markdown, which is basically a very simple, basic language for formatting text. And to make it pretty when it gets displayed. But at this point, it doesn't really matter. There's going to be a few things I'm going to explain, but still, it's just plain text. So here we have shortstory.md. And now when we flip over to run the command, run the test, we'll see what happens next. It says I'm running test for the short story, and it says I performed 0 tests, 0 passed, 0 failed. So at this point the system is telling us that it couldn't find any tests. Why? Because no tests are written here. It's just blank line. So if we recall what we talked about in the presentation, we said once we create the file, what is the next thing we want to do? We want to tell the machine that the story, short story, must have title. So we say it by formally expressing our expectation that says it must contain title. Now flipping over and running again, it says I'm running tests and I fail because I found a story file, short story, but that story does not contain title. So now we have to add title to the story. Now how do we define title? We're using Markdown, and in Markdown a very simple syntax is hashtag, and we can say story title for now, something like this. So this hashtag will be understood by the machine that it implies title, hashtag space, right? Now if we flip over and run again, we see that it passes. It says story contains title. It says I performed 1 test, 1 pass, 0 failed. So the system is telling us what it did and is informing us, whether the script is running, and it's telling us, yes, I have ran through all your expectations, and for now I found only 1, and this passes. It's satisfied. Your short story indeed has title. Okay, so you see how we're going step by step. Now what's the next step here? I usually like to, when I'm writing a story, just give it some kind of a skeleton, which probably means chop it into a few segments. And in this case, I'm going to do it, this is the story. We're going to go back to the unit test. I'm going to do it by formulating another expectation, which is I'm going to chop it into several subtitles. So I'm going to say minimum number of subtitles, and I'm going to chop it into 4. So what I'm saying here is, now that my story contains title, I'm expecting it to have 4 subtitles. And once we do that, we flip over and run again. Alright, so what do we have here? It says first test passes, it still contains title, but the next test, the expectation, fails. And it says this story has 0 subtitles. And I was expecting minimum of 4 subtitles. So obviously we now have a broken system. We broke it because we formulated an expectation that the story does not contain. And now, as we talked about, you feel this urgency or this impetus to fix it. Like, I gotta move forward. And I don't have to think hard about many other things. I can just go and say, look, what I need to do to push this thing further is to give it 4 subtitles. And in the Markdown syntax, subtitle is basically 2 hashtags and space. So very simple. It's smaller than title, so it's subtitle. So the first one I'm going to call exposition, and the second one I'm going to call it rising action. The third subtitle I'm going to call how should I call it? Maybe climax. Let's see what happens when we save now and run again, because we only have 3. Again, you see that it says it fails. Story has 3 subtitles and minimum number is 4. So we have to keep going. And the last subtitle I'm going to call resolution. And these are typical, skeleton for a typical story. Always starts with exposition or introduction, and then there's some rising action, and then there's a climax of the action, and then some kind of resolution. And for now we keep those. We can change them, but for now we keep just reminding ourselves of the arc of the story, right? Let's run again and see what we get. Oh, look at this. We now have both tests pass. So it says I performed 2 tests. Oops, this is too much. I performed 2 tests, 2 passed and 0 failed. Okay. Now let's keep going and see what we have here. We got ourselves a short story with a title and a skeleton. We now flip over to tests and we can say, okay, so now that we have the skeleton, what do we want to do next? What is our next expectation? And the first thing that comes to mind is it must also contain, I would say the story must contain the end, so that we know the bookmark. Okay, beginning and the end. Flipping over and running the test. Okay, so now it ran 3 tests, 2 passed, 1 failed. The first one, of course, continued to pass because we still have the title, we still have 4 subtitles, that hasn't changed. But it fails because it does not contain the end. And now to fix it, what do we have to do? Simply tag the end to the end of our story, to the end of the story file. And if you run again, all right, so now we have performed 3 tests automatically, all 3 pass, 0 failed. Great. Now is the time to flip over to our test and say, all right, we have 3 expectations, all 3 expectations met. What do we want to do next? How about the opening? And I'm again saying, okay, this story must contain a proper opening, and I will call it Once Upon a Time. All right, typical opening. If we run the test, we will say, okay, we have 4 tests. First 3 pass, nothing changed there. The new one fails because the story does not contain once upon a time. And now we are prompted again to fix it. So in the exposition, we're going to say, once upon a time, and I'll say a stranger moved into the house next door. So it's an opening of our story. What do the tests say now? Oh, all 4 pass. So it's all expectations are satisfied. We flip over and we look at our 4 expectations. Great. Now we're starting to think about more expectations, and because I already have some idea in my mind, I'll throw a few things in that I think should be necessary part of this short story. And I'm thinking about the story will involve my 2 dogs. So it must contain 2 dogs. Run the test. It says pass 4, and the 5th one fails because it does not contain 2 dogs. I have to fix it. And I go into rising action, for example. My 2 dogs were barking a lot. My neighbor was annoyed by the barking. Something like this. I'm just making this up, right? I want to test it again. What's going to happen is all 5 tests pass because all the expectations have been met. It has a title, 4 subtitles, it has the end, it opening once upon a time, and it contains 2 dogs. Okay, keep going, keep rolling. We got more expectations. I'm going to say must contain, for example, warning sign. I'm doing a little bit of plot thickening, warning sign. I always run the test whenever I make a change because I want to see it fail. And indeed it fails. 6 tests performed, 5 passed, the last one fails because it does not contain warning sign. Alright, over to story writing craft, and I can say one day I noticed my neighbor put up a warning sign on his front lawn. Let's see if the expectations are now met. Alright, 6 all pass, everything's cool. Keep going. Now I'm thinking about what's next, but now that we have the warning sign, I'm also interested in what's on the warning sign, right? And my expectation is that the story must contain the phrase "no dogs on the lawn." That was hard to guess, eh? Alright, run the test again. And we have 7 tests. All the first 6 pass and the last one fails because our story does not contain "no dogs on the lawn" phrase. We need to fix it now. Maybe it's easy to fix. The sign read "no dogs on the lawn." Alright, what do the tests think now? Okay, now all 7 pass. We're in the clear. We have a fully working story up until now. Good. We're going back to our expectations. So let me see, what else do I need to do? Am I expecting here? Maybe I want to say must contain I took my dogs for a walk. I know this sounds very contrived, but it's just to illustrate how we are going, and of course this is not a real case usage. Well, let me run the test now. Okay, so 7 passed, this 8th one fails because obviously our short story does not contain I took my dogs for a walk. I need to fix that. Go back to the story, and I'll put this in the climax section. One day, the same day, I took my dogs for a walk. Run the test. Everything passes, 8 tests, everything's cool. Next expectation. Must contain, I'm continuing with shaping my story and throwing some significant phrases. My irate neighbor. Okay. So the story now must contain my irate neighbor. Let's run the test. Of course, it must fail. One must fail because the last one, it does not contain my irate neighbor. Let me fix that. The dogs went onto my neighbor's lawn. My irate neighbor, sorry about typing, yelled. Neighbor saw them and yelled. Let's see how does that work for the system. I'm hoping all nine pass. Okay. So we can continue with saying must contain maybe exclamation. Hey you. I'm just driving the story now. Running that. Okay, it fails because it does not contain hey you, which gives me the prompt to go and say hey you, no dogs on the lawn. So my neighbor saw dogs and said, hey you, no dogs on the lawn. Let me run the test. Passes. And now my next expectation is it must contain I see 2 dogs. Run the test. Okay, the 11th one fails because it does not contain I see 2 dogs. I'm going to quickly fix that. I replied, I disagree. I see 2 dogs on your lawn. What happens now? I see 2 dogs. Oh, I made a mistake. 2 dogs and exclamation point. Okay, see, the test caught my incorrect. Alright, 11 tests pass. It's awesome. Okay, so now what is my next expectation? So you see the climax or the tension is now at all times high, and I would like to move into resolution. And what do I expect in the resolution? Just contain. I was worried. It fails because it cannot find I was worried. Quickly fix that in the resolution. At that moment, I was worried that my neighbor will get angry at me. Run the test. 12 tests pass. Beautiful. What is the next expectation? Is must contain we both laughed. Run the test. The 13th one fails because the story does not contain we both laughed, but let me finish this up. Instead, he looked at me and we both laughed. Okay, let's see what the tests say. So, sorry, the casing. We need to fix the expectation actually this time. Alright, or 13 pass. So now pretty much our story is fleshed out. First draft, right? Just kind of first pass. My neighbor was irritated, but then when I cracked a joke, instead of him getting angry, we looked at each other and laughed and became friends, hopefully. Let's now look a little bit more at some other expectations possible, right? Let's say we have and now this is the thing where it becomes interesting, because unlike maybe writing a short story or writing a story, which is a solitary activity, when we are developing software and developing many other things, we work as a team. And so these expectations could be coming from elsewhere, not just from me, right? Or I may be working for a publishing house and my editor may be sending me these expectations which I have to fulfill. Because if I hand the story over, they can run these expectations and see if something breaks. So, for example, oftentimes, there's some expectations such as minimum number of words. Let's say they say, okay, look, you want to publish this story, but at the minimum, we need 100 words. Let's see, how does that fit here? Pass. Okay, so this story so far has 130 words, and expected minimum number is 100 words, right? Now, what other expectations can we kind of put into this story so that we get to, let's say we can also put maximum number of words, of course. And we can say maybe, let's say if maximum number of words is 140, so between 100 and 140. Oftentimes we do have some stringent requirements. Well, this passes because it's 137 still. But let's say if we said 130 words, then a story will be broken because it has 137 words, but the maximum has 130 words, right? So at this point, maybe leave it at 200. We can also have expectations such as maximum number of paragraphs. This is a little bit contrived, but who knows? Maybe there's some kind of expectation that they say, okay, maximum number of paragraphs 8. For whatever reason, we're saying no more than 8. Okay, what did I do wrong here? Maximum number of paragraphs. Let's say minimum. Oopsie, sorry. There's a glitch here. This doesn't seem to be working, don't matter, because anyway it's contrived. And lastly, maybe the length, so we can say minimum length is maybe 200 characters. It passes because it has 666 characters. And we can also say maximum length is, maybe, let's say 600 characters. And it fails because it exceeds. But for now we'll leave it at 700. Then, okay. 16 tests, they all pass. Things are looking good. So to wrap it up, to review, we have here shown in a very simplistic way how we can work either solo or as part of a team, where we can first express some expectations, let the system pick them up, let the system run them and show us what's broken, and then it guides us to go back and make it work. This is also not only good for guiding our thinking and kind of keeping us within some kind of a straight and narrow so that we don't meander, but also this now serves as a good safety net or guardian against regression, because we maybe as part of a team share this story in this shape with some other writers, and they may make some changes that will break this. Now, when they give us changes back, first thing we do, we run tests and we say, oh look, this is broken, you have exceeded number maximum, or some of these words and phrases are missing. Same thing is happening if we want to publish it. We send it to the publisher, they run the test, and they say, okay, wow, it used to work, but now somebody changed some content in the story and it doesn't work anymore. You need to fix it. So very similarly, when we are writing software and programming computers, we have the similar approach. We do it step by step, and each step we verify. We always run the entire system, and we can see that everything is still working. And later on, if somebody inadvertently makes a change, then these tests will warn you, say, okay, something is broken. Okay, so with that in mind, I hope I managed to shed some light on test-driven, this mentality, and who knows, maybe some of these things can be useful for people who are writing things or sharing information and putting some formal constraints on the content as well, and a little bit of a structure such as number of paragraphs, number of subtitles, maximum length, minimum length, etc. All right, hopefully this didn't manage to confuse you, and I'm looking forward to your questions and comments. Thank you. Bye.